Question, lecturer in mathematics from Kontai Polytechnic. Today's my presentation is about cross product and its properties. The cross product of two non-zero vectors a and b is denoted by a cross b and is defined by a cross b equals to magnitude of a vector, magnitude of b vector, sine theta n cap, where theta is the angle between a and b and it lies between 0 to 180 degree. Also, n cap is a unit vector which is perpendicular to both a vector and b vector. That is, n cap is a unit vector which is perpendicular to the plane containing a vector and b vector. Here, an important thing is about angle between two vectors, that is theta. If the angle between two vectors is theta, then there is another angle between two vectors which is 360 degree minus theta. In case of dot product or cross product, we always consider the smaller angle, which we always keep it in mind. Now, from the figure, we see that a and b are two vectors, angle between them is theta. A vector a cross b which is perpendicular to both a and b, and there is another vector which is b cross a and that is perpendicular to both a and b. Here also we see that a cross b and b cross a are in opposite direction. Let me explain this. In the first step, we point the fingers of right hand along vector a. In the second step, we curl the fingers in the direction of vector b. Then thumb gives us direction of vector product a cross b. অর্থাৎ যদি আমরা ডান হাতের আঙুলগুলোকে a বরাবর রাখি এবং আঙুলগুলোকে আমি b এর দিকে ভাঁজ করি, তাহলে আমাদের বুড়ো আঙুল যেদিকে থাকবে সেদিকটি a ক্রস b ভেক্টরের দিক নির্ধারণ করবে। Otherwise, if we point the fingers of right hand along vector b and we curl the fingers in the direction of vector a, then thumb gives us the direction of vector product b cross a. অর্থাৎ যদি আমরা ডান হাতের আঙুলগুলোকে আমরা b অভিমুখে রাখি এবং আমরা এর অভিমুখে এর দিকে ভাঁজ করি, তাহলে বুড়ো আঙুল যেদিকে থাকবে সেটি b ক্রস এর দিক নির্ধারণ করবে। এভাবে আমরা দেখতে পাবো a ক্রস b এবং b ক্রস a পরস্পর বিপরীত অভিমুখে থাকবে। Now here some important observations. First one is a cross b is a vector. From the definition of cross product, a cross b equals to magnitude of a vector, magnitude of b vector, sine theta and n cap. We know that magnitude of a is a scalar quantity since length of a vector is a scalar quantity. Similarly for magnitude of b, sine of their angle, that is also a scalar quantity. So magnitude of a scalar, magnitude of b scalar, sine of some angle, that is a scalar, n cap is a vector. So right hand side is a vector quantity. So a cross b is a vector. We always keep it in mind. Now the second observation is, if a vector and b vector are two non-zero vectors, then a vector cross b vector is equal to zero vector, that is null vector, if and only if a and b are parallel or collinear to each other. অর্থাৎ এখানে a cross b 0 হবে যদি এবং কেবলমাত্র যদি a এবং প্যারালাল a এবং b প্যারালাল অথবা একই রেখায় থাকে, একই রেখীয় হয়। First one, if a cross b equals to 0, then from the definition of cross product, magnitude of a, magnitude of b, sine theta n cap equals to 0. Since a, b are non-zero vectors, so magnitude of a and magnitude of b not equal to 0. Then obviously sine theta is equal to 0. We know that theta lies between 0 degree to 180 degree. Sine 0 is equal to 0 and sine 180 degree is equal to 0. So the angle between a and b is equal to either 0 or 180. If a and b are if the angle between a and b is 0, then it is parallel in the same direction, they are parallel in the same direction or collinear. Again, if theta is equal to 180 degree, then the vectors a and b are parallel but in opposite direction, that is anti-parallel. Again, if a vector and b vector are parallel, then the angle between them is either 0 or 180 degree, that is parallel or anti-parallel. Then from the definition of cross product, a cross b is equal to magnitude of a, magnitude of b, then sine of 0 degree or sine 180 degree, both are 0. Therefore A vector cross B vector is equal to 0 vector. So A cross B is equal to 0 vector if and only if A vector and B vector are parallel or collinear. Now properties of cross product. If A, B and C are three vectors and they are in R3, or that is A, B, C are in three spaces, and lambda is a scalar quantity, then the following properties are true. First one is A vector cross A vector is equal to 0. If we have a vector A and cross it with itself, that is some vector, same component, then resulting vector is going to be equals to 0 vector. It is also clear, it can be proved from the definition of cross product. A cross A, that is magnitude of A vector, magnitude of A vector, and sine of angle between them, that is sine of angle between A vector with itself, that is sine 0, and some vector quantity. So right hand side is vector quantity. So A cross A equals to 0 vector. You always keep it in mind. Now the second property is A cross B is equal to negative of B cross A. The second property is telling us if we were to take the vector A and cross it with B, then this is same as negative of vector B cross with vector A. Already we explained this. আমরা দেখেছি যে A cross B এবং B cross A দুটি ভেক্টর পরস্পর বিপরীতমুখী। A cross B ম্যাগনিটিউড ভ্যালু এবং B cross B এর ম্যাগনিটিউড ভ্যালু সেম, বাট তাদের ডিরেকশনটা অপোজিট ডিরেকশন, they are in opposite direction. So A cross B is equal to negative of B cross A. We can say commutative property does not hold for cross product, because commutative property says A operation B is equal to B operation A. Here A cross B is equal to negative of B cross A. So commutative property does not hold for cross product. Now the next property is A dot B cross C is equal to A cross B dot C. It is telling us if we have the vector A, if we were to dot product it with vector B cross C, the result is going to be equals to the vector product A cross B dot the vector C. This is a dot product. So we first do the cross product B cross C and do the dot product with A, or if we do the cross product between A and B and then do the dot product with vector C, then the result is going to be same. Now the fourth property is A cross B plus C is equal to A cross B plus A cross C. The fourth property is telling us that if we have three vectors A, B, C, like A cross B plus C, this is going to be equals to A cross B plus A cross C. This property is known as distributive property of cross product. Now the fifth property is lambda of A cross B is equal to lambda A cross B is equal to A cross lambda B. It is telling us that if we have a scalar quantity lambda and if we were to distribute it to the vector A cross B, then we can do it two different ways. One is we can distribute the constant to vector A and then cross product with vector B, that is like lambda A cross B, or we can distribute it to vector B like vector A cross the scalar quantity times the vector B, that is A cross lambda B vector. So any one of those ways representing is correct. Now we want to highlight the next property. For mutually perpendicular vectors I, J and K, we have I cross I is equal to J vector cross J vector is equal to K vector cross K vector equals to null vector, that is 0 vector. From the definition of cross product, I cross I is equal to magnitude of I sine 0 some vector. Since I is a unique vector along x-axis, therefore magnitude of I equal to 1, magnitude of I that is 1 sine 0 angle between I with itself, any vector with itself equal to 0, so sine 0 equal to 0, and some vector that is I cross I is equal to 0 and some vector is equal to 0 vector, that is null vector. Similarly, for j cross j is equal to null vector and k cross k is equal to null vector. Now, the cross product between I and j is going to be k vector. From the definition of cross product, I cross j is equal to magnitude of I, that is 1, magnitude of j, that is also 1, sine of 90 degree, because angle between x axis and y axis, that is 90 degree, sine 90 1, and a vector which is perpendicular to both I and j. We know that I, j, k are unit vector along coordinate axis. So, the vector which is perpendicular to both I and j is k vector. So 1, 1, 1 and k vector, then right hand side is equal to k vector. So I cross j is equal to k. Similarly, j cross k is equal to I and k cross I is equal to j. One easy way to remember this, from the given figure shown in the circle, if we want to travel in this way from I to j, then j to k, then k to I, in that direction, then there will always be a positive quantity. That is, if we want to travel from I to j, j to k, k to I in that direction, then there will always be a positive quantity. If you travel in opposite direction, that is from I to j to I, or I to k, or k to j, in that direction, then there will be a negative quantity. So j cross I is equal to negative of I cross j, that is minus k. Again k cross j, that is negative of j cross k, that is equals to minus I. Similarly, I cross k is equal to negative of k cross I, that is minus j. So those are some properties of cross product which we want to keep in mind. That's all. Remaining part will be discussed in my next presentation. Thank you.